All right, section 8.1. The whole chapter, let's see what the whole chapter is. It's right triangles. I don't know if you remember, but several times during the course of the year, we've talked about, okay, we're doing triangles in this chapter and, and all that stuff. And then we talk about right triangles. And I've mentioned a couple times that there's even a chapter just on right triangles. That's all this chapter is about. Is just on right triangles. Not just triangles in general, is just on right triangles. Like, how in the world is there so much information just on right triangles? Well, you wouldn't believe. There's whole entire courses just on right triangles. It's called trigonometry. You ever hear that?
Yeah.
Okay, trigonometry, or they shorten it, they say trig. All right? We're not going to do trig today. In fact, we probably won't do trig until maybe the end of this week, early next week, something like that. Okay? But today we're going to start off something, and I'll just write it down. It's called the geometric mean. M-E-A-N. Now, you've dealt with the arithmetic mean. When I say arithmetic, I'm talking about arithmetic, okay? Right? So the arithmetic mean is basically just finding the average between two numbers. This is really not technically the average between two numbers. I really don't even have a good explanation for it of why they call it the geometric mean. Let's not worry about that. Let's just worry about how to use it, okay? So this is what they're going to ask you. They're going to say, what is, I'll write it down, okay? They'll say, what is the geometric mean between these particular two numbers? And they'll give you two numbers. Okay, what is the geometric mean between these two numbers, okay? And let's just start off easy. Let's just say between 2 and 5. All right, just pick two numbers out of the blue. It says, what is the geometric mean? This is what we're finding, the geometric mean. Let me show you a little way to set this up. Basically, it's a ratio. We had a whole chapter on the last chapter about ratios.
These are the fake. These are the ones that got messed up. I just brought them for fun.
Okay, oh, that was fun. All right, so here we go. This is what we do. We set up a proportion. A geometric mean basically is a proportion. We spent an entire chapter, didn't we? Last chapter, talking about proportions and ratios and all that kind of stuff. Well, this geometric mean is a proportion. Now watch what we do. The geometric mean, I'll do in another color. I'll do it this pink-purple color. X is the geometric mean. So X is going to go right here, and watch this. X is going to go down here. Everybody watching? Okay, so this is what we're solving for. We're solving for X. So X is going to go up here on the top left, and X is also going to be in two places. It's going to be down here on the bottom right. Everybody see that? So when it says geometric mean, that's the first thing you do. You write two ratios, you set them equal to each other, so it's a proportion. You put X in one corner and X in the other corner. Now if you wanted to, you could have put X in the top right, but where do you think the other X should go if I put the X on the bottom left? As long as they're diagonal to each other, okay? That's where you're going to put your X. What does the X represent? It represents the what? The geometric mean. So if they ask for the geometric mean, that's what you're solving for right there. And again, what is it? Like, what is it? What is it? Is it the average of the two numbers, or what? I really don't know how to explain it, tell you the truth. That's why I'm not going to explain it, okay? But it's very, very useful and stuff we're going to do a little bit later, all right? It's going to be useful to solve missing parts and missing sides and stuff on things that we wouldn't have been able to solve for before, and it really comes in handy. So if it says this is the geometric mean between 2 and 5, where do you think the 2 and the 5 are going to go? Yeah, 2 is going to go here, and the 5 is going to go here. Now, again, it doesn't really matter. I could have put the 5 down here on the bottom, but what would I have to put up here on the top? I'd have to put the 2. Notice, the 2 and the 5 are diagonal to each other, aren't they? The x's, the geometric mean, they're diagonal to each other. Make sense? All right. And now, what do you think we're going to do to solve for this? We're going to cross multiply, exactly right. So let's cross multiply. So if I multiply this times this, what do I get? What's x times x? It's not 2x. Yeah, what happens when you multiply something by itself? What are you doing to that number? You're squaring it, right? So x times x is x what? Squared. Good. And then let's cross multiply the other one. So 2 times 5 is 10. Just like that. So far so good, isn't it? All right. Now, we've talked about this. How do you get rid of a square? I think we have. Yeah, because when we've done Pythagorean theorem, right? Yeah, so we've done this. Say it, Dion. Square root it. That's right. So I'm going to square root both sides. So x squared equals 10. I'm going to square root this side. I'm going to square root this side. It's not 5. What happens to that square root in the square? They cancel each other out, and you're left with x. You're right. Now, what about this? No, it's not 5. Because what times itself is equal to 10? 5 times itself is not 10. It's, well, is it 2 point something? It's 3 point something because what? The square root of 9 is what? 3. 10 is a little bit bigger. Nah, it's not 3.5. I don't really care what it is, tell you the truth. Because you know how I'm going to write the answer? You know how I'm going to write the answer? Just not square root over. It's just the square root of 10. All right? That's how you write your answer. Just write it like that. Yeah? Let's do this. Let's get my calculator out just to show you what's going to happen. Get Dion. What was your question? Right. Yeah. If it comes out even, yeah, write it as a 5. Like if it came out to the square root of 25, write it as 5. If it came out to the square root of 36, then write it like that. But if it doesn't come out even, just write it like this. All right, so let's try it. On this calculator, I hit square root. I have to hit second function this button. Now, a lot of you guys have that TI-30, which is actually my favorite calculator. I like that one better, all right, than this. As far as this regular kind of arithmetic goes on a calculator. I mean, this does a ton more things than what the TI-30 does. But as far as this basic stuff, the TI-30 is a nice calculator to use. So it's just wait till we're done here. So this is the square root of 10, all right? And remember, the square root of 9 is 3, isn't it? Okay, and then 10 is a little bit bigger, so it's probably just a little bit bigger than 3. My guess, 3.1-ish, something like that, okay? And then, yep, there it is. So it actually rounds to 3.2. So if you wanted to, now listen, you don't have to do this, but watch. If you wanted to, you could write it as a decimal. If you took it to one decimal place, it was 3.16. So what does that round to? 3.2. Tell you the truth, I would just keep it square root of 10, wouldn't you? I mean, why bother putting into a calculator when I would accept this answer, right? Just taking the square root, my answer is perfectly fine like this. So there's really no reason to change it into 3.2, but you can if you want. Now look, 3.2 is between 2 and 5, isn't it? Now it's not the average though, is it? What would the average of 5 and 2 be? It'd be 3.5. This is not 3.5, is it? So it's the geometric mean. It's not the true arithmetic average. It's not a lie. It's the geometric mean. It's a different kind of a mean. All right, but it does lie between 2 and 5. It is between those two numbers, somewhere between. Okay, not dead on halfway in between, but somewhere in between. All right, we good with that? Does that make sense? Let's do another one just for fun. Find the geometric mean. I'll just put some numbers down between, I don't know, 7 and, let's say, 4. Or 4 and 7, doesn't matter. Find the geometric mean. Okay, I'll just shorten this up. Geometric mean. Is that all right, GM? Find the geometric mean between 7 and 4, 4 and 7. Go ahead and do that real quick. It's a big difference. All right, here we go. Watch. Where does the geometric mean go? First of all, the very first thing that I do is I put an X here and an X right here. Okay? And then what goes in these other two spots? 7 and 4, or 4 and 7. Doesn't make any difference. So watch. Cross multiply. Cross multiply. Is that our answer, 28? I've heard of several people say 28. You got to take the square root of both sides, right? So it's the square root of 28. Now, I'm really tempted to talk about simplifying these radicals, but I'll leave that to your Algebra 2 teacher, okay? Because even the honors class had a fit with simplifying square roots. So I'll just let you keep it square root of 28, or you could punch it into a calculator. And let's see. Well, let's see. Square root of 25 is 5, right? So 28 is a little bit bigger than 5, so it's probably close to the 5.3, 5.4 range is my guess. It's a complete guess. So it's the square root of 28. But do you need to go through this? No. So it's about 5.3. I was right. Okay, so x is actually not equal. I put a little squiggly equal. What's the squiggly equal? What did I say, 5.3? It's approximately equal to, not similar. It's approximately equal to 5.3. It's not exactly. What's the exact answer? That thing right there. That's an exact answer. Everybody see? And I'll let you keep it like this. This does actually simplify. I'm not going to make you guys worry about simplifying that. Just keep it the square root of 28, and that would be perfectly fine. I'd put a check mark by it on a quiz or a test, and check mark's always a good thing, right? On my test. I've seen some teachers put check marks when it's wrong. To me, yeah, you ever see a teacher do that? To me, that's so weird. That's just contrary to what a check mark means. Check mark means, yay, good. Check it off the list, you know? Check mark, to me, doesn't mean wrong. That means right. X means wrong, don't you think? Yeah, X marks the spot. Okay, here, why are we doing the geometric mean anyway? Well, I'm glad you asked. Because, go quickly, okay? Watch. Here's how we use this. Let me try to draw this about like that. And let's make this come back in like that. That's alright. I know. I'm sorry. Is that better? A little bit. It's still coming. Oh my goodness. I don't really care, to tell you the truth. We're going to keep it like that. Alright, now watch this. I'm going to make this a different color. Watch this. What I'm going to do, I start off with a right triangle, correct?
Wait, should we be writing?
What do you think?
Yeah.
Okay, if I'm putting it up here, you should be writing it down. I'm sorry. Alright, so watch this. I just drew an altitude, didn't I? From that right angle. Remember an altitude? We did that last chapter. I think it was last chapter. The altitude goes from a vertex perpendicular to the opposite side. In this case, I went perpendicular to the opposite side of the right angle. So what do we call this side right here? This big side right here. It's opposite a right angle. Hypotenuse. Very good. This would be the hypotenuse, wouldn't it? Okay? Watch what I'm going to do here. Let's put this next part in blue. I'm going to call this side A. I'm going to call this side B. And I'm going to call this side H for height. Is that alright? Is that okay? Alright. Well, that's what it is. Alright, this is A, B, and the height. Now look, listen to me. If you're not paying attention, I said, listen to me. You're acting very guilty. I said, if you're not paying attention, then you're going to be lost for the rest of this thing. Okay, so right now you really got to pay attention. I put the A, the B, and the H in different colors. The reason I did that is because the A, the B, and the H are all three geometric means. Remember I said find the geometric mean? We made it X. Well, this is actually a geometric mean. This B is a geometric mean. This H is a geometric mean. But between what two numbers? Right? Because before I said, what's the geometric mean between 2 and 5, right? What's the geometric mean between 4 and 7? Well, A is a geometric mean between two numbers. B is a geometric mean between two particular numbers on this triangle. H is a geometric mean between two numbers on this triangle. All right? Let's just, I tell you what, let's use the same numbers that we did earlier. Let's use 2 and 5. Is that all right? So that little piece right there is 2. That little piece right there is 5. You understand where the 2 is going from? It's going from here to there. It's a segment, all right? It's not the whole hypotenuse, is it? It's a part of the hypotenuse. It's a segment of the hypotenuse. The 5, where do you think it goes from? From here all the way to here. Does that make sense? All right. Now watch this. I'll do this in blue since my geometric means are in blue. There's 3 different things. There's 3 different geometric means. I'm going to have 3 different little proportions here. Let's do H first. H is a geometric mean. So if H is a geometric mean, this is how we set it up. Where does the H go? Where the X's went. Exactly. So H goes here and H goes right here. Everybody see that? All right. Now, we got to understand the hardest part about this is not understanding which ones are the geometric means, but between which two numbers. Okay, is this a geometric mean? Well, h is a geometric mean between these two segments right here, between 2 and 5. So guess where I'm going to put 2 and 5? Right here and here. See that? This is something that you have to memorize. You have to know that the altitude, this height right here, that's why I called it h. This height right here is a geometric mean between the two segments, listen to me, the two segments of the whole hypotenuse. What's the whole hypotenuse? Which is what? 7, isn't it? Okay. So h is the geometric mean between what? The two parts of the whole hypotenuse. Everybody got that? All right. So if these were different numbers, you'd put the different numbers in there. And we can solve for h. We'll do that in a second. Everybody with me on that? It's very important that you see that. H is a geometric mean between the two segments of the whole entire hypotenuse. That's the easiest one. The A and the B are the ones that are a little bit tricky, but actually A and B are very, very similar to each other. All right, so what we're going to do is we are going to say, remember, A is a geometric mean as well. Remember I said that earlier? So A is also a geometric mean, so that means A would go here and A would go here. Agreed? Because A is also a geometric mean. So the two sides of the big right triangle are geometric means, and this altitude right here is also a geometric mean. So I said A is a geometric mean between what and what. Now this is the part that you have to watch and pay attention to. Everybody watching and paying attention? Watch. A is the geometric mean between the whole hypotenuse. What is the whole hypotenuse? It's 7. And now listen to my words here. Between the whole hypotenuse and the segment of the hypotenuse that's adjacent to side A. Which part? What are the two segments? 2 and 5, right? Which one of those two parts is adjacent or next to side A? 2 is. And that's it. It's not too hard, is it? Well, B is kind of the same thing. Remember I said A and B are kind of similar to each other? So B is also a geometric mean between what? What do you think? I said it's very similar to the whole hypotenuse, 7, and what is it, Brooke? 5. Good. You see that? So H is the geometric mean between the two segments themselves, right? 2 and 5. A, one of the sides of my big right triangle, is a geometric mean between what? The whole thing, right? And the segment that's adjacent to A, or the part that's closest to it. So that would be 2. Do you see it? Between the whole thing, 7, and the little bit that's closest to A, 2. 7 and 2. Look at B. B is a geometric mean between the whole thing, 7, and the part that's closest to that, which is 5. Now look, if I didn't know this stuff, there's no way I could solve for A and B, or H in this situation, is there? There's just no way, because I can't use Pythagorean theorem, because look, I only know the hypotenuse, that's all I know. So I can't use a Pythagorean theorem, so I got to know something else. And this is something new that we would have never been able to use before. We've never been able to solve for A and B before today, and now you should be able to solve for it. Okay? So watch. H is a geometric mean between 2 and 5. So there's my geometric mean, 2 and 5. You got it? A is a geometric mean between the whole thing and the side that's next to. Do you see how it's closest to A? All right? So 2 and 7. You see it? 2 and 7. B is the geometric mean between the whole hypotenuse and the segment that's closest to B. All right? And now we can actually solve for those three things. So now let's do the math. That's not even the hard part, is it? It's just setting it up is the hard part. So let's do it. It's h squared. We've already done this once today, haven't we? 2 times 5 is 10. So h is the square, not 10. It's the square root of 10. Look, remember, the square root of 10 is 3 point something, right? It's like 3.2. 3.2 is not the same as 10, is it? You can't just write down 10. If you write down 10, it's not the right answer. 10 and the square root of 10 are completely different numbers. Got it? All right. So that's one answer. So that's the length of h. Okay, which is around what? What I say was 3.2? All right. But we'll just keep it the square root. Let's do this one. Cross multiply. What do we get? A squared equals 14. So A equals what? The square root of 14. And that's your answer right there. You don't even have to put that into a decimal, do you? Kenny, still with me? All right. Come on, fight it. Fight it. All right. I can see it's taking you over. So watch. B times B, that's B squared equals this, 35. So that's the easy part, isn't it? So B is what? Square root of 35. Now look, square root of 35 is just a little bit smaller than what? Square root of 36. What's the square root of 36? 6. So square root of 35 is probably like 5.8 or 5.9 or something like that, wouldn't you think? Okay. What about this? This is a little bit smaller than the square root of 16. What's the square root of 16? Square root of 16? No, square root of 16 is 4. Okay. So this must be a little bit smaller than 4. Would you agree? All right. So there you go. That's your answers right there. If you wanted to, you could put this into a calculator. We already did the square root of 10, didn't we? What was it? It's 3.2 around 3.2 approximately, right? Square root of 14 should be just almost 4, right? So let's try it. Square root of 14 is 3.7, almost 3.8, but 3.7 we'll say. So that's approximately. Let's do this. This should be what? Square root of 35. Should be real close to 6, right? So like in the 5 point something big, right? So square root of 35, and that's, yep, 5.9. So 5.9. But it's approximately. All right, so those would be the lengths of these sides right here. Everybody with me? And that's how we can find it. What do you think? That's not too hard, is it? You just have to memorize the little, I guess you could call it a formula, but remember what we're trying to do right here. All right. All right, if you don't remember this from your notes, if it doesn't make sense, look back on the YouTube. Hopefully that'll make a little more sense. Remember, there's 3 of these things, right? 1, 2. I am giving you a worksheet, yes. All right, so there you go. Look, please, let's get this stuff.
Seriously, guys.
Because I'm a little frustrated with my honors class because so many people mess this
I
up.
heard.
And I just don't understand how they could mess it up when, to me, it looks pretty, yeah, I think it looks easy. I hate to say easy, I know, because everybody yells at me because I say it looks easy, all right? But I think it's definitely something you can handle. Let me give you a worksheet, and then you can do that tonight.